Let's continue. Worst case, no, kapag talagang kunik ulit, magre-record na lang ako. Sige. So, let's continue with the response spectra. So, 1.5. Then, ano naman si S sub 1? Spectral response parameter ng 1 second structure. Content story. 1 second. Kaya kita nyo, no, itong document na to, no, Pivots did this in collaboration with Asce. Kasi nga, for consideration sa transition natin sa IBC. So, for 1 second, and then Manila, orange ulit, no? I-interpolate na lang natin between 0.5 and 0.6 G. So, that's 0.55. Natin 0.55. Okay? Next, long period transition. Ito, hulaan ko lang muna ito kasi ano lang naman ito eh. Nagbavari yan sa for 3 second ano, masyado na mataas yan. Hindi naman tayo magde-design muna ng 30 story. Okay lang yan. Leave it as 3 lang. Then soil type D. So naalala nyo yung sa UBC natin, yung nag-dictate sa atin is the soil type and the distance to the fault line. Siyempre, kung ano yung zone mo, distance. So, tatlo lang na yun eh. Tayo dito, yan, soil type. Dito, wala na pinag-usapang distance kasi nga, in-indicate na ng map yung specific spectral acceleration natin per location. And even the zoning, eh, no? Kasi nga, because of the map, no? Regardless of your zoning, yun na yung mismong value ng spectral acceleration. So, next. Next is, so, site coefficients. Site coefficients. So, dito, ina-amplify ng code yung spectral acceleration. Because, iba nga, sabi natin, yung SS and S1 na yan, sa bedrock. No? Now, by indicating yung soil type above the bedrock, ngayon, magkakaroon ng factor to amplify that. Through this, FA and FB. So, makikita nyo, for example, SS is 1.5. SS is 1.5, ito siya. Greater than 1.25. Tapos, soil type D. So, ang FA natin ay 1 also. Parang wala na bago. So, 1.0. 1.0. Wala na bago kasi i-multiply yan later on sa SS. No? 1 times 1.5 is still 1.5. Next, F sub B. F sub B. Yan naman partner ni S sub 1. So, S sub 1. Right now. Yeah. So, type D. Tapos, ang S1 is more than 0.5. Kasi 0.55 tayo, no? Let's sulat ko ah. SS, S1. Ito yung mga sulat. 1.5, 0.55, 1.5, 0.55. Yan. So, our S1 is greater than 0.5. So, ito tayo. Dito. So, ang ating F sub B, F sub B ay ito, 1.5. Okay? So, 1.5. Okay? And ito na yung magiging spectral response acceleration parameters. After considering the FA and FP. So, multiply lang naman. No? So, 1 times 1.5, siyempre 1.5, and then 1.5 times 0.55 is 0.825. Na-amplify na. Na-amplify. Next. But remember, this is MCE level. You know, 2,500 year return period. Okay? Eh, di ba, nagde-design tayo ng structure for a 500-year return period. Kaya ang formula ni code ay 2/3 SMS. Basically, multiply mo na sa 2. Okay? So, yan. So, 1.5 times 2/3 is 1. And then, 0.825 times 2/3 is 0.55. SDS is 2/3 SMS. SD1 is 2/3 SM1. So, SDS, meaning design, pag-design na siya. Design spectral response. Okay. Yeah. So, set SDS 1. Bakit 1? Yan. So, yun na. Yun na yung pinaka-response vector. Ito siya. Okay. Yan yung response vector. Yung, okay, kung i-edit ko naman ngayon yung pang base share. No? Pero hindi ko priority yung base share ngayon. But for the sake of getting the base share, no? Or comparing with UBC, we'll discuss that. I mean, we'll discuss using the spreadsheet. No? Hindi ko na i-discuss in detail yung ibang formula muna. Anyway, hindi ito yung governing code pa sa atin. Pero gusto kong kasing makita nyo yung difference ng IBC sa UBC. So, kung po i-building 5-story, kung a typical height is 3 meters, that will be 15. 3 times 5. 15 meters. C/T 0.0731. Kasi concrete. Okay. 0.0466 pala dito. And then teka. Tapos si English units pala. meters. Ano ba naman ito? Meters naman. Sige, 0.0466 natin. 0.0466. Ano naman? Okay, 0.5. Okay. Response. Sorry, R value pala. Sorry. Reduction factor. 8 as per IBC. Next. Direct category 2. Basically naman, yung important factor niya is 1. Pero pag school, no, may special kang gawing 1.5 eh. Pero stick muna natin sa 1 para hindi maka-apekto sa ano no, sa base share. Gawin natin normal to 1. Okay, next. Okay na, tapos na. So this is our base share. Ang priority ko yung C sub S, yung coefficient. Mag base share is equal to a certain coefficient times the weight of the building. So ito yung concern ko. Baka yung multiplier. Di-differentiate natin. Okay. Ang nag-base share is this. And ang nag-govern na multiplier is 0.125. So 0.125. Okay? 0.12. Yan yung nakuha sa sa IBC. Now, with regards to the response spectra, natin. I-rewrite ko siya dito.
Magkakamuhan talaga.
This is 1.35. One. Ayan. So this is 1.0. Ito ay 0.4. Okay. So kung T sub naught, no? Then T sub naught, formula niya ay 0.2 SD1 over SDS. So anong natin? Ang SD1 then 0.55 and 1 eh. 0.2, 0.5 over SDS 1.0. Yeah, you should get 0.11. 0.11. Okay. Okay. 0.11. Next is T sub S. Base ito 0.55. Kaya kasi T sub S natin, kasi ang SDS naman natin is 1 eh. Ito naman yung T sub S. Ay, hindi kita. This is T sub S. So which is the formula ay SD1 over SDS equal to Yung SD1 natin ay 0.55. SDS ay 1. 0.55. Okay. Yan. Now, so this is 1.0 also. Okay. Okay, tapos ito ay 0.11. 11. How about yung ito? Nakikita nyo meron dito siyang so 1 second. Ito yung T sub L mo, yung 3 second na dinefine na. Pero yung 1 second mo, that's SD1. So 0.55. Sabihin, so 1 second na period mo, kung ito ay 0.55, so tansyahin ko na lang, roughly na, dito yung 1 second. Dito yung 1 second. Yan. The value niya should be 0.55. 0. Tapos ito ay 1.0. Okay? Tapos yung T sub L natin ay 3 seconds. Kaya ang formula naman nun ay SD1 TL over T squared. And at T sub L for 3 seconds. Kahit tansyahin nyo na lang ito. Anyway, yung slope niya is pag kinonect nyo yung slope niya, pag continuous, no? Hanggang T sub. And yung, by the way, yung value niyan is ito pala ito. Baga ito, that is SD1 over T. Oops, sorry. SD1 over T. Yan yung formula. Naalala nyo ano yung formula niya sa UBC? CV over T. Yan naman siya. CV over T naman siya. Now, kung i-relate ngayon natin sa sa POE building, 15 meters in height, ano yung period natin? 0.533. 0.533. So, ibig sabihin, kung 0.533 yung period natin, remember, this is 0.55. Ito. Yan. Ayan. Ito ay 0.55. 0.533 lang yung koi building. So, ibig sabihin, nandito siya. So, pasok sa loob niyan si koi building. Which means, nandito siya sa peak. No? Nandito siya sa peak. Kaya ang governing niyang spectral acceleration is 1G. 1G yung governing niyang spectral acceleration. Okay? 1G. Then next is, punta ngayon tayo sa base shear. Sabi nga natin how 0.125 was derived. Di ba yung season S niya? Yung 0.125. 0.125. Yes. So the formula is ito. SDS I over R. No? So yan. C sub S is equal to SDS I over R. Yan. And if you will multiply that, so diba, ang SDS natin 1.0. It's 1.0 times 1.0 divided by the R value 8. No? 8. When you multiply that, or when you operate that, you will get 0.1. Kasi yan yung formula ng peak. SI, IOB, 0.1. Meron pang other formula. So, 2.129. Okay. So, concern ko lang muna yung response spectra and yung 6 sub S. No. Now, if you compare that with UBC, tayo sa UBC, balitan natin ito, gawin natin 15 meters, 0.56, no? R is 8.5, so type SD also. Zone 4, distance is 10 kilometers. You will have 1 in 1.2, NA and B. Gawa na natin ito last time, si ACB. So what's the governing fish here? 2480.4. 2480.4. Huwag kayo tuloy sa value. Yung kung ano yung nag-govern na formula. No? Doon lang muna. Kung gusto nyo yung next. Tingnan nyo yung ano yung nag-govern na formula? Vmax. 2.5 CA IW over R. So still, sa UBC, no? Ito yung ano natin. Comparing UBC and IBC. Okay. Comparing UBC and IBC, same sila na sa Vmax ang nag-govern. Kasi sa ito, this is IBC or ASC 710. Ito pa rin ang nag-govern. Nandun siya sa zone ng Vmax. And ganoon din sa UBC, nandun din siya sa zone ng Vmax. Now, as to the coefficient, tingnan naman natin yung coefficient. No? Ano yung coefficient ng Vmax? So, 2.5 CAIW over R. So, titingin ko lang. So, UBC dito, UBC 97. So, Vmax is equal to 2.5 CAIW. R. So, kupitin ko lang yung 2.5 or C sub S niya is 2.5 CAI over R. Yan yung nag-govern ng coefficient. No? So, 2.5 times CA is 0.44 divided by R, which is 8. Ito na lang i-type. So, equals 2.5 times 0.44 divided by 8. 0.12941. 0.12941. Or roughly 13%. No? 13%. Okay? While what we got sa IBC is 0.125. Almost 13% pa rin, no? Or 12.5%. See? So, what do you notice? No? So, lumalabas, no? Mas maliit, no? Mas maliit si IBC. Mas maliit si IBC. Okay? But you will see, no, although different attack approach yung ginawa natin, we use spectral acceleration map sa IBC. Sa UBC, yung Philippine map na may zone 4, no, tapos distance to fault line, then dictating the soil type. Kita nyo, no, halos yung base share mo, ganun pa rin. No? Okay? But there's a tendency sa IBC na pwedeng mas maliit yung base share mo. Kasi nga, yun yung advantage ng spectral acceleration. Mas exact na yung ini-indicate natin spectral acceleration. Unlike sa UBC, no, just by distance, no, online ako ngayon, sir, this week. Next week ako papa-exam. Okay. Ayan, no? But with regards to the spectral acceleration, response spectra natin, no? Ito yung UBC, no? And you will see yung kanyang spectral acceleration peak umabot pa ng 1.1 G. 1.1 G. While si IBC is just 1 G. Mas konti, mas maliit ng konti si IBC. Okay? Yan yung advantage of having a spectral acceleration map. So, yan yung gagawin nyo sa plates nyo. Instead of just using UBC, ang gagamitin nyo naman to compute the base year is also this IBC using the spectral acceleration map of the Philippines, published by DOST Volts in collaboration with Asce. May Asce yan. Itong nandito. Yeah, ito yung current Asce president, si Engineer Ison. Okay. And in fact, nung tinuro ko to last year, no, may chance na because for example, itong sa Mindanao lang. So, sabi nga natin kanina, sobrang pula, no, ng Mindanao. So, may malaki ang chance sa Mindanao na if you will compare the base year using UBC 97 versus sa base year sa IBC, mas malaki yung base year ng IBC because of this large spectral acceleration. Kita nyo, 2.1. Kalakas yung niya, spectral acceleration. More than 1. 2.7, 2.9. Okay, so question. Madami recordings ako i-upload kasi nag-i-stop lagi. So you see, no, ito yung application of studying response spectra. Because for me, kung hindi nyo na-aral yung diniscuss natin na ito, spectral acceleration, hindi mo ma-grasp yung idea of spectral acceleration. By knowing this theory, then the numerical methods approach, paano na-derive to, at least you ano, you will now understand bakit yun ang ginagamit sa code. Why we need to use spectral acceleration map in using or in getting the phase shear using IBC. By the way, no, I'd like to demonstrate a software. Ito nga yung Seismo Signal. Ito, this is of course, ano yan, binabayaran to. No? Pero fortunately for me, meron akong license courtesy of the structures. I-import ko lang yung earthquake data, for example, Loma Prieta, open. Yeah. So, may recordings, pag may recordings ka ng ground motion, of course, time and acceleration. Yan. Input ko lang yan. Okay. Na-import na niya yung ground motion. Yan. So, velocity, displacement. So, punta lang ako sa response spectra. Yan. Ano ba yung response spectra? Acceleration versus period. No? Then refresh. Click refresh. Yung response spectra. Very fast. No? But again, as I said, yung algorithm niyan, the same do sa ginagawa no? Using spreadsheet. Siyempre, mas mabilis na dito kasi automated yung paggawa. Yan ang response spectra nung earthquake na yun. You want to get the displacement, same trend, no? Habang tumataas yung period and structure, lumalaki din yung displacement. For the velocity, acceleration, ito. So ito yung earthquake to. Yung Loma Prieta, umabot ng 1.35 G. I think meron din ako dito ng yung Pampanga earthquake yan. Research. Ito, whole earthquake. 30. Okay. Na to, DBM Pampanga earthquake. Take note no, before I close this, 0.35 G yung PGA niya. Pero yung peak niya 1.35. So you can see the difference. Yung El Centro 0.32 G, nag-peak siya ng 1.1. May konti pang angat eh. So 1. Almost the same, no? Almost the same. Now, how about itong DBM? Then, okay. Read. So this is seismos natin. Ito na siya. So yung acceleration niya is just ano lang to. 0.04 G lang. Hindi ko lang na scale lang. 0.04 G lang. Ito yung response spectra niya. Yan. 0.04 G lang. So scale down nyo lang. Centimeter per second square kasi siya. Change units. Centimeter per second square. Okay. Then sabihin natin last night 46,000. Kung ano, 40,000 lang. Kasi sobrang haba ng duration na nakuha ko. Kaya nag-warning. Yan. Yan. 40 centimeter per second squared. Okay. And take note, itong recordings na to sa DBM. Just across the bridge lang. So, elastic, fresh. Naka-units na siya ng centimeter per second squared. So, ang 200 centimeter is just 2 meter per second square. 2 meter per second square is only 0.2 G. Na-imagine nyo, no? So, ito ay 0.04 G. Ito ay 0.2 G. Baga, superimpose natin si el sentro na 1.1 G. Ito ay 0.2 G lang siya. Ganun ito, 0.32. So, yung 0.2 nandito lang, no? 0.04 nandito. Ganun kaliit yung recordings na yan. Okay? Envelope na envelope siya ng response spectra ni LCF. And if you will superimpose naman yung NSCP, ganun din. Sobra-sobra pa si NSCP. Okay. Sige. So, yan yung quick way to generate response spectra. Kaya kung nagpagawa ko ng response spectra sa inyo, you can verify your answer using this software. Okay? And nakita nyo, nag-ano siya, no? Ito, nag-pick siya sa, anong period yan. So, ipo-project ko yan downward, roughly 0.8, ba? No, ganun, no? Or 0.9, second building, or 9-story building, no? Pwede mag-resonate siya. Again, sa DBM to, sa DBM. Dito sa Pampanga. Pinangalanan ko ng Pampanga because doon yung epicenter or somewhere there, Palace. No? Pero sa DBM yung recordings. Kaya ganun ka kababa yung kanyang pitching. That and question. And then, kita nyo, dumping values, no? 5%. Kaya sabi ko sa inyo, halos lahat ng software, yan ang default, no? Yung 0.05 or 5%. Okay? So now you know the difference between IBC and UBC and the purpose of knowing the response spectra. Okay. So, last position, no? Kung let's say we're analyzing a 10-story building, no? Instead of COE, no? Let's say we make this 30 meters, no? 30 meters. So, magiging natin, C sub S is 0.069. So, kanina, 0.125 yan. No? 0.1. Now, it's 0.069 because the period of your structure is 0.9 or almost 1 second na. Double check nila ito. Kasi sa ASCE na table to, hindi sa NSCP. Anyway, basta malaki. No? And as you see, so wala na siya dito sa zone na yan. Nandito na sa zone na to yung ating 10-story building. Ito na siya. Ito yung COE nandito. Nasa peak. Kaya lumiit na yung ating CPS. Okay? Yeah. And also, before I forget, no? Take note, no? Yung Yung spectral acceleration natin is 1. No, but we're using only 0.125 sa phase shift. Again, why? Because we incorporate the value 8, which is, you may say, the ductility factor. Okay? You can imagine, no? You can imagine na, so lalaki yung poste mo, lalaki yung section ng building mo if you did not reduce the spectral acceleration. Di ba? Yung coefficient of phase shift. That's why dito nga papasok yung ductility factor by introducing this R value. No? We have a separate discussion that parang ang concept ni code is ang design-based earthquake naman natin is once every 500 years. Ang lifespan naman ng structure, di ba? Hindi naman tatagal ng 500 years. No? So we incorporate this R value, the ductility factor, no? Ensure na ductile yung structure mo. So reduce natin base shift, so that you design, it results to a smaller dimension, pero make sure na ductile yung structure. Okay? Yung ductile na siya. Okay, following the seismic detailing. So that's the concept of the phase shift. So after generating the response spectra, we reduce that by a certain value R. Okay? In consideration of the ductility of the structure. Okay? So that's it. No more question. Then do the attendance. Stop the recording.